Let me get the chat working here in case anybody has any questions. All right, now we got it. So what we're going to do today is look at printing with ABS, and then we're going to talk about problems that I had with that board, the SKR Mini E3 version 2 board. We've worked them out, but it wasn't a obvious thing what was going on, so it took us a little bit to figure out what was going on in there. And I've got one other little thing that we'll add to the printer because of what we've added here. So what we added is this enclosure. ABS, the material when you print with it, it's a good material, but it has two kind of big drawbacks. One of them is that when it prints, it is a little bit noxious. So like the printing fumes from it. Not talking about the particles necessarily. There are research projects that have been done and continue to be done on if printed particles, like micro or even nanoscopic, maybe very tiny particles that are emitted during printing, if they're dangerous for you or not. And some research indicates maybe they are, others indicates that it's not, and most of the time it boils down to how are your printers positioned. Are they in a tiny little space where you are, or in a big space with lots of circulating air where you are? And so that's not really what I'm talking about, though. I'm talking about just the smell of it itself. And ABS is one of those that can be a little bit noxious to smell as it's heated up. Kind of like any other kind of plastic that you melt, well, not melt, but heat up. And so that's one thing, is just the smell of it as it prints. And there's other materials like that too. It's not just ABS. The other thing is that ABS can be susceptible to bad interlayer adhesion or warping. And if it is not allowed to cool at its own rate, like if you force it to cool or a draft comes around and cools it too quickly, then it warps as it cools. If it cools down slower, then it remains, where you put it. And so both of those things make it easier to print ABS inside some sort of enclosure. For one, you contain the smell, and then you can exhaust it out where you want it to go. And if there are particles, possibly you can remove them at the same time also. And you can eliminate drafts and heat swings, but in the chamber itself when you enclose it. So what I did is I bought an enclosure. You don't have to buy an enclosure. A lot of people use very simple enclosures, some cardboard. The very first printer that I printed ABS on, I just used a cardboard box basically, and put it around the printer. And so it might have even been the box, or at least part of the box that the printer shipped in. And so that's one thing that I have done before. Some people, I don't know if I like this idea as much, but I have seen plenty of people who just use a plastic bag over the printer, because you're not trying to do much other than keep errant drafts, air drafts, current airflow off of your ABS print, and enclose the area so that it retains the heat that you put in. The heat is just coming from the heated bed for the most part, and I guess a little bit from the nozzle. And so you're just trying to contain that heat. So you could do all of those things almost free. Probably slightly cheaper than what I've done here with the fabric enclosure is using some IKEA tables. The LAC table is about perfect size to go over the top of a Ender 3 size printer, and then you put something on the sides, and you can let me look up LAC enclosure, and you'll see some for a 3D printer. See some examples. Oh, here's one. Actually, this is somebody building one on Etsy. Let's see. So they kind of look like this. Here's one. Here's kind of a pretty standard LAC enclosure. you can go to Thingiverse or one of your favorite download, model file sites, and get these little connectors printed, and then the legs here and the top are a table from IKEA basically, and it's a relatively affordable table, assuming you have a way to get IKEA parts to you without enormous shipping costs. And then the sides in this particular one are some either plexiglass or Lexan, I don't know. And so you can do that and have a nice looking one that's a little bit cheaper than this one. The one that I ended up going with was this guy. So it's kind of expensive, $80. That's a lot. It is substantial, so it's not just a bag. I don't know if it's exactly worth $80 compared to some of the other options. It does have some nice benefits. For one, you could take it down and collapse it into a small package if you don't want to have it standing out all the time. You just need it temporarily. But then if you just need it temporarily, there's much cheaper solutions like the cardboard or the bag or whatever. If you want something more substantial, the nice thing about these is it is a table, so you could use it to put things on top of it. You can't really put things on top of this one very well. It is fabric. I don't even have a way to show you. Here's inside the one, so it's pretty big. So there's the Ender 3, and you can kind of just catch one edge and then the other, but it's actually a pretty large printer enclosure, so it can handle Ender 3s. It says it can handle Ender 5. I suppose that is possible. The 5 would probably fill up most of the space, but it probably would fit in there. One thing that I haven't done is I've left the electronics and the power supply electronics, I've left them in here, so they're also getting heated up. That is not ideal, but it's so far it hasn't been a problem. I think that I will probably at some point, if I keep using this enclosure, will probably want to remotely locate the electronics so that they don't get heated up. I did do some things to mitigate that, and those things could have been what caused my problems with the SKR board. I'm not sure. I don't know when they started because I wasn't paying attention of when these problems actually started. We'll get to that in a minute. So since I can't show you, I mean, it's hard to show the bag. It's pretty big. You can kind of get an idea. Oops, except I locked up the video. We'll have to get that back. Let's see, where are you at? Maybe it came back. There we go. But it is a large space consuming thing. I did remount the filament on top. I don't really like it up there. I've told you that before. It does work fine as long as you're not printing super fast and it creates some kind of resonance with this inverted pendulum type effect on top of your printer. And it hadn't been a problem. I'm not trying to print super fast with this stuff. It's going regular speed, I guess. Not slow, but not in the super fast speed. It gets dark in there, so we're going to fix that today, hopefully. With this, let's show you what I got for that. I actually took it off of an older printer, but this little light bar that goes across the top, it also plugs in the same way that buck converter, step down converter that we had. I took it out. We'll talk about that also. It plugs in the same way, so it just plugs in between your power supply and your motherboard. So it's super easy to install. It's got a couple of screws that mount it to the top of your printer up here, and it's just a LED that's dimmable. It has a little rotary switch here to turn it on and off and dim it. So we'll put that in there. The only downside to this thing, I've had it on another printer before, and you can even see it in the picture, is that since it's up at the top, it creates a shadow right across the bottom of your printer because it's shining right above the print head and the x-axis. So that's a little downside to it. I think I will leave it alone for now, but it might be reasonable to print some extensions where it's further towards the user and tilted down so that all the shadows get pushed to the back. I'm going to just mount it on there the way it is right now, though. And it's super easy. We'll install that in just a minute, actually. So I had been using just a flashlight to be able to see in there because it was pretty dark when you close it all up. The door is open on it right now. Let's see. So why don't we put that on right now, because it really doesn't take any time. What you do is you unplug back here. So, well, right there, we unplug that, and we got the little. Now it came with a like 3M adhesive deal that is long gone, so we'll just mount it some other way. Let's see. Other way. There. And there. So that's all we do to actually install the power for it. Now we'll have to mount this somewhere. I don't want to cover up the fan, but maybe it does have. One thing I don't like is this part is very short, so the controller has to be pretty close to wherever we put the light bar. So that's a downside to me. I wish it was a little longer, but I guess maybe they made the choice that if it was too long, it would potentially get tangled in your print. Maybe, I don't know. I think it could have been longer. It just uses T-nuts for mounting it to this rail. So, oh, but that would make it shine up in the air. So let's turn it over. Kind of like so. The printer I had this on wasn't one that was in an enclosure, so I just tried it out to get some more light on the printer, because a lot of times I was ended up shining lights on it or whatever to try and see what was going on, and I wanted to have something more permanent. So this is what I don't like, is, you know, this kind of thing just kind of hangs here. You can try and attach it. It's supposed to be attached maybe at the back, and it's hard to reach. On the side, there's not really a lot of surface area, plus you get in the way of this. You do lose a tiny bit of height because you know, this can or will collide with it. I don't think it's ever going to affect anything, because it would have collided with the very top of the bar anyway. Let's turn it on. There's kind of what you get. You can dim it. That's how bright it gets. So much brighter in there. No more need for a flashlight. Let's talk about what I did. I did move the Raspberry Pi, so I did have it mounted right here. I did take it out, and it's running through a little flap over here on the side. This is also the power supply. This entire panel is velcroed in. This, you can kind of see the edge of it right there. Not the whole side, but a little panel on the side, probably a foot square. It's a Velcro panel that you can remove. Right now I'm just using a section of it opened up to bring power in and bring the USB from the Raspberry Pi that's running Octoprint. I moved the Raspberry Pi out because the Pi that I'm using doesn't have a fan on it. It just has heat sinks, and it was already a little bit concerning to me when you have a Raspberry Pi running with no cooling at all for that long of a time. It would probably be okay, but then I went and heated the chamber, so I don't know. I just set it outside. It's sitting right on the other side of this wall, and then coming in here. There are lots of pockets and little holders on the outside. I guess I could maybe attach it to the thing. It's just sitting on the table. So other thing I did is the cooling fan here. Since I didn't take these electronics out, there is a fan under this little, you know, duct right here. There's a fan. It is only on certain times. So basically, it was plugged into fan 1, and it would come on when the layer cooling fan came on. I think it would come on. It came on periodically, and I wanted to be on all the time. So let's look at this pinout. So here, let's see. Here is where it's normally plugged for the box fan, the fan that goes inside the control box. I unplugged it from there and wired it into here. So this is the same that the nozzle heatsink fan is on. So it's just on. It's whenever you turn the printer board on, then those fans come on now. So the little box controller fan is on, and this fan is on. Both of these are on as long as the printer is on. So that will keep, or hopefully keep, the electronics in here cool enough. I was also afraid that being in an enclosure that was heated, now it doesn't get super hot, but when I'm printing ABS on here, this bed is about 80 degrees Celsius. So it does get warm, and you can tell that it is warm. I'm going to get a thermocouple in here so I can kind of measure the ambient temperature and see where we're at exactly. I don't know. I just know it's warm. And so I wanted these on all the time, so they come on all the time. And I don't know if doing that created my problems or if they were already existing and I didn't notice it before. So the problem is that this, see, I don't know how to change color. We'll just use this. This fan is fan 0. That is the layer cooling fan. Now, ABS you can print with no layer cooling and it will work pretty well. In fact, when you first started printing a couple of years ago, and all of the home level printing was new, everything was so poorly controlled that layer cooling fans basically just cooled everything, and that didn't work well for ABS. And so you were told, don't use a layer cooling fan for ABS. Well, now that you have more control, now I've got an enclosure. I've got fan ducting that kind of directs the cooling exactly where you need it to go. There's a silicone sock on the hot end to keep it kind of insulated. So there's a lot more control over where the heat is. Now you can probably do better. In fact, I have a print right here. So this print, let's see, let's do it this way. This print is, I don't know if I'll get it to focus on the right thing doing it that way. Let's look down. So this print is without a layer. These are little pawns for a chess set from Thingiverse. This one is no cooling. And you can see a pretty big, I don't know, it doesn't show up. There you can see, So right in here you've got some droopy layers. There's one that's not even attached. I don't know if you can tell it or not. Pretty bad Z-seam, pretty visible. No layer cooling. Same print, but with 50% fan, so not 100% layer cooling, but half on. You can still find the seam. There's the seam. Not nearly as pronounced as this seam. Oh, wait, you can't see that. There we go. You can still see it. You can kind of pick up some of it right there, in fact. But this piece with the little bit of cooling is much better than this piece with no cooling. And they're both ABS, both the same material. It's a Matter Hackers ABS gray. So some amount of cooling on ABS is a good thing. You just want to be able, I don't know if you would want 100% fan on all the time, and that's where my problem started. So I have, normally fan 0 is the layer cooling fan. That's the default fan for layer cooling. And it's controllable. It can be pulse width modulated from off to full speed. It's a 24 volt pin on this Ender 3, and it can vary between 0 and 24 volts. So that's perfect for what I would want to do. In Cura you can set, in fact I probably need to go ahead and open Cura so we can look at it at some point. I assume we'll want to look at that. You can set the amount of layer cooling. You can set a maximum fan speed and an average fan speed and what layer to kick on and all that kind of stuff. So you have control over it in the slicer or through the menus on the printer itself. But mine was either on or off. Like that was it. And I couldn't always control when it switched one way or the other. So what had happened is, let's erase some of these. This little guy right here is a little MOSFET, so a little voltage regulator type of setup. And it had quit working reliably, and basically it was just on. So I could unplug the fan and have it off, or 100% on. And so that was it. And I got to looking around on the internet, and this is a pretty common thing on these E3 boards from SKR, even on the version 2. And it's like it looks kind of large on this picture, because this picture is about twice as big as the actual board, and it's a really tiny thing. It is a surface mount MOSFET. You can technically unsolder it and resolder a new one if you have one. They're super cheap. It's not an expense thing. It's just they're tiny, and I don't have one on hand. But I do have fan 1 available. So fan 1 used to be the controller box fan, but now I have the controller box over here on the always on power. It's just on. So I thought, well, we'll plug it in over here, and that's fine. Except to do that, well, so this one also has a MOSFET that whatever killed fan 0's MOSFET could potentially kill fan 1's MOSFET at some point in the future. It hasn't, or it didn't last night. I haven't actually checked it today, but it had been working, so we'll assume it's still working. So to do that, you have to go in. It's not as simple as just plug in the board, or plug in the wire from here to fan 1, from fan 0 to fan 1. That physically works fine, but you have to go into your firmware and tell the firmware that the layer fan is going to be on fan 1. So to do that, you got to get your Visual Studio open. Now I'm using the Big Tree Tech unified firmware for version 2. I'm using that, and you've got, let's see if I can kind of put it back to where it normally is. So normally you're over here working in configuration aids, or maybe the advanced configuration. Maybe you change your boot screen, to a different picture or whatever, but normally you're over here. But if you go into this one, it's normally minimized like that. So if you go into the source, or whatever, I assume SRC means source, but I don't know. Pins, so you want to define what the different pins are. This will be a different file structure if you're just in plain Marlin. It probably won't have what you're about to see here. So in here, there are all these different board types. Remember, this is a unified firmware that kind of should be universal between a bunch of different types of printers. I don't know what this file structure looks like if you're in just plain Marlin, but the files we're going to find will be similar. And so we have the STM32F1. If you open that part, so it was closed, you open that. In there, there's the Big Tree Tech SKR Mini E3. This says common. So these are file pins that are common between all of the STM32F1 compatible boards. And then you have another file in here that is Big Tree Tech SKR Mini E3 version 2, and you have the 1.2 and the 1.0 also. So you need both of those files. So I've got them open here. Here's the common one that we're looking at, and it's got several different things. There's a statement. It's got an include that it's going to include these in whatever this is, environment validate. A lot of different things here. There's a servo pin, X and Y stops, Z stop, Z probe stuff, filament run out, power loss, all these temperature sensor pins, and there's the fan pin. All right, so normally the fan pin is referring to the fan that is the layer cooling fan, and so it was PC6. This was this green line here was the original line. So PC6. I need that to be on fan 1 instead. So I changed that to PC7. And then over here in this is the common file. And then in the one that's specific to version 2, you have a similar line where I want fan 1 to be PC6. So anytime fan 1 is referred to, which is supposed to be the box cooling fan, the controller box cooling fan, I'm going to refer back to PC6, which isn't working for me anymore. I've got the fan in the box just always on, so pin 6 is not being used by me. So I'm just going to, instead of trying to find all the instances of fan 1 in all of these files, I'm just going to redefine. Anytime you want to use fan 1, just try to use pin 6, which was fan 0, and nothing should happen. And it's fine because I'm just using that fan as always on. So, and anytime you want to actually use the layer cooling fan, use pin 7, which is labeled as fan 1 on my board. And so we did that. And that now I have a controllable layer cooling fan until that MOSFET goes out. So it's a little bit of a pain to do that. I know that in Cura, when you set up a printer, so if we manage this printer, there is a extruder 1 cooling fan number. You can change this to 1, but it doesn't. There are too many other instances of the part cooling fan not being fan 1 that it doesn't work. I couldn't make it work. I did try this first because it seemed like that'd be way simpler. Just tell it that the cooling fan is fan 1 in the slicer, but the firmware, I suppose, overrides that at some point, and it wouldn't work. So that didn't work. Changing this to a 1 by itself didn't work. So I had to go into the firmware and change them in the pins files of the firmware. So if you ever run into that, you do have 2 fans. You can always have your control box fan just always on and switch over to fan 1. You just have to go into the pins file in the firmware that you're using and switch those around. So it wasn't terrible, but it took a while to figure out. In fact, failing, the other part of this failure was that in the process of failing, when that MOSFET on the board in here failed, the fan failed. So I don't know which caused which. Maybe the fan failed and somehow that caused the MOSFET to fail, or the MOSFET failed and that caused the fan to fail. But I had to switch out for a new fan, so you can kind of see a couple of wires here that are not bundled with the others because I had to replace that fan also because it was completely dead. So it's always good to have a couple of spare parts around so that you can do things like that. Otherwise you're stuck. Now you can print, like I said, you can print ABS with no fan at all, but the prints are going to be a little bit sharper with a little bit of fan once you get past the first couple of layers. I'll show you in Cura how I have it set up. So here's how I have the fan set up in Cura. I have it as at 50% enable print cooling, 50%. If you have any layers that are 8 seconds or shorter, then I could put a maximum fan speed of faster for, like, if a really short layer might need to have more cooling so it doesn't just melt into a big glob. I'll show you that in a minute too. Then you can have that set to maybe 100, and really short layers ramp up to 100% cooling. Like if you have spikes or pointy bits on the top of something, then that might help. But mine are just set at 50%. It starts at layer 4. So the first 4 layers, well, the first layer is completely off, and then it's regular, so 50% at layer 4. So layer 2 is like 16%, and then it's like 30%, and then it's 50%. And layer 0, or layer 1, is 0%. Here are some examples of bad cooling. So here you can see a little calibration cube. It didn't warp or anything, but the top layer, this is only 3 top layers, and you can see that there's holes in it, all sorts of negative looking parts here. This is pillowing. I don't know if we'll be able to zoom in close enough so you can see the pillowing part. It's kind of blurry. Come on. Focus on that. And you can kind of see how it looks like little lumpy pillows on top of it. That's pillowing. And also there's holes in there. That is either you're printing too hot, you're printing not enough top layers. So this is, I don't remember the infill, maybe 20% infill or something like that. So there's not enough support for the layers to land on. So it's usually a combination of those things. Not enough layers, and you're really hot printing. And you do print ABS. I think I'm printing it at 240. Let's see. Yeah, I'm printing at 240. So it is a hotter material to print. And so that combination with no cooling produces some pretty bad results. It's on the top layer. The sides look fine. Now there is a little bit of deformed layers in the Y. Again, it just won't focus where I want it to, or maybe it can't focus that close. But you can kind of see a little. The Y doesn't look quite right. It's indented a little bit. That's also the same kind of insufficient cooling. Same print, but with more top layers. Still no cooling. You get a better top surface. It's still kind of lumpy. You can kind of see it's not as flat. The Y is still indented. This one also had a couple of ridge lines here from something binding. I don't actually know what it was. So cooling, that's where I wanted to add a little bit of cooling to ABS. So as long as you have layer cooling fans that are directing the cooling just to the layers and not blowing just randomly everywhere, and you are printing pretty hot, you got the heated bed on, it is okay to cool ABS some. And again, I'm only cooling at 50%, and it does make a pretty big difference in the surface finish of the part. ABS also does like to warp. You can kind of see where it's stuck down there. I've been using this, and this is a PEI sheet, and I've been printing everything with a brim. To the very first part I printed, this one, you can see a tiny bit of warp on that front left corner. I don't even know if you can tell in the picture. It's not a lot. Typically, whenever you have parts that have sidewalls, like a box, maybe a box sitting on the bottom with the walls sticking up, those walls are going to want to peel up at the corner. And so you're going to need something that's going to hold ABS down. Even if you have no cooling or anything, you got the enclosure and everything, it's still going to want to peel up some. And so a brim is usually useful on ABS prints. Remember, the brim is the one that attaches to the part itself, and they're not hard to remove. Let me just make sure we know what a brim is. So here's our part. This is, I think we made that in class, maybe. I can't remember now. So I think we did. So brim, when we slice, it's gonna connect to the part itself and give it some more area to kind of grip the surface. It doesn't matter if it's a large part or a small part. ABS typically needs a brim to hold it from warping that first layer. That's not 100% true all the time, but it's, close enough that I just put a brim on. They're easy enough to peel off later, and it saves. Even if you do get some warping, now you have something you can tape down, so you can tape the brim back down if it starts to peel up the brim too. So I do print with the brim. You can see kind of, well, you can't see if I cover it up. Kind of see, this is all it does is you can peel it off pretty easy. Assuming you don't have it squished down to the point that it is hard to remove, but they're pretty easy to remove. Usually I run over it with a deburring tool, or this one probably couldn't get a deburring tool in there, just a knife or something, and it'll clean that edge up. I actually did it on that one. The reasons you might want to print in ABS are it is tougher material. So if you think of the stress strain curve for the material, there's more area under there. It's actually not necessarily stronger, like it's a PLA is a little, has a steeper modulus of elasticity, a higher modulus of elasticity, I would think. So it's more rigid, but it is a little more on the brittle side. The other thing is that I'm printing this at 240. It has a higher glass transition temperature. So ABS, you can expose to higher temperatures and it doesn't soften. PLA, you get it in a car in the summer and it's going to soften. You know, it won't turn into a puddle necessarily, but it's definitely going to deform. Where ABS probably is going to be able to survive that. The thing that I like about ABS, those are good things, but the thing I like is that it works so much easier for sanding or anything like that. I did a little bit of sanding. I don't even know if you'll be able to pick up anything on this, but let's see if we can figure out how to, maybe if I put it down here so that it'll focus on that. Yeah, I don't know. No, you can start to see here. All right, so this part at the top, up in here, I sanded with, you know, just a few seconds with one of these guys, and it's not that it's blurry on the screen. It really is completely smooth. You can actually polish ABS. In fact, if you spend enough time sanding and finer grit sandpapers, you can polish it till it shines. And you can't do that with PLA. PLA sanding, you can sand PLA. Now this is kind of blurry on the screen. It doesn't look like there's layer lines, but there definitely are. There are none here. They're sanded away. So it works so much better for sanding. So if you want a part that you want it to be smooth in the end, you're going to have a much better chance of achieving that with sanding ABS than you are sanding PLA. And then you have the benefit of it's also going to be a little bit tougher part, so it has some flexibility to it. It's going to survive higher temperatures, and you're going to be able to treat it. You can treat it with acetone. Let me see if I have some acetone. I do have some, but I don't know where it is. Oh wait, I see it. So PLA doesn't do this, or at least not nearly on the same level. But ABS is it dissolves in acetone actually. But you can use a small amount of acetone. I'm just gonna maybe do this. Just a little bit of acetone on here. And it will, you probably can't see, I can't see what I'm doing and what you're seeing at the same time when I'm doing this. Now normally you use acetone vapor. I don't have a setup for doing acetone vapor. Plus acetone vapor is pretty flammable. Acetone is very flammable, but then you atomize it and it gets very flammable. Paint, oh, okay, so what I do a couple of different things for paint. One thing I use, let me see if I can find it. And this step is probably not necessary, but I do, let's zoom back out. I do spray this on, usually it's an adhesion promoter for automotive plastics is what it's for, but it just helps things stick. It's not necessarily a primer, it's actually clear, but it's just an adhesion promoter for if you're going to paint onto plastics. So I usually do this first, and then I will spray something like, let's see if I can find one of the primers. I don't have a primer handy right now. I think I've used. Oh, there they are. Hold on. Now, I have one of the primers here. I do use two main kinds depending on what I'm trying to do. So if it's a big model that I'm trying to print and you know, it's, I don't know, a larger surface or whatever, it doesn't have a lot of detail, then I'll use a automotive sandable primer, just because most of those, they're either thick enough that they'll fill in some of the layer lines, particularly useful on PLA because it's a thicker primer, like a sandable one or filler primer, something like that. Just a spray can, not like a whole spray gun setup. I'll use one of those on bigger stuff. On smaller stuff where I don't want a thick coat of primer, I want to save the details, I use these things. So this would be for like a little model that you're building, you know, a styrene model of a car or whatever. So these are thinner. They do prime so that your paint will stick, and then but they're thinner. So this is a white one. They make different colors, and they don't occlude all of your details. And then when I go to paint, usually what I'm using on the smaller things are just acrylic paints, either the craft paint from Walmart, Hobby Lobby, you know, the what's it called, apple barrel paints or whatever they are. I do have some more expensive paints, like if it's a detail thing. Let me see. Where are you at? So this is one of many different types of paints, but the little guys like in here, these are all acrylic paints, but they cost more. What they give you is very high pigment ratio to solvent ratio, so you don't have to put as many coats on to cover the model. So if you're trying to retain detail on a little small model, this kind of paint, it's going to cost more. Not necessarily this brand. This is I think this is a Reaper paint. Yeah, ReaperMini.com. So this is a Reaper paint, but the ones in this type of bottle are typically Model Master, Reaper, those brands, Army Painter, all those kind of things. They're expensive and tiny amounts because they have a very high pigment content, so you don't need as many coats, and so you can retain the detail. If I'm printing or painting a big thing like a helmet or something that size, then I'm probably just going to spray it with the matching Duplicolor type thing. Usually, if you're going to, you know, I'm not going to paint by hand something that's got a large surface area, and usually large surface area doesn't need to retain these tiny little details. So tiny things, I use the tiny bottles because you can use fewer coats and retain a lot of your detail. Bigger things, I usually use the bigger stuff because I'm not interested. There's probably not details I'm trying to save on there or anything like that. I just want it covered, and that works fine. On both of them, I usually do spray. This is pretty thin, or at least you can put it on pretty thin. I usually do spray this. Sometimes if it's a really small model, I will just do this without the adhesion promoter. But those are typically the kind of things I paint. Maybe one day we'll do we've got a few classes left that I have kind of ambiguous ideas of what we're going to do. One of those could be a painting different things day. It's going to be hard I can't spray paint in here, but we could do the hand painting, and I could do the spray painting ahead of time. So what I was saying about that acetone is you can smooth the parts of ABS printed parts with just acetone. You can literally paint the acetone on. Too much acetone and it'll just melt. You can actually drop this into a glass container of acetone, and this will completely dissolve, and it creates a slurry. So you can use that slurry as a bed adhesion. You paint it on your bed on your printer, and it will, as it heats back up, that the acetone that's melted in the ABS that's melted in the acetone will grab onto the part you're printing and really hold it down. And back in the older days, that's how you held prints down, is you would take ABS, put it into a container of acetone, let it dissolve completely, and then paint that slurry onto your print bed as an adhesion. You didn't have PEI sheets and stuff like that back then, or at least I don't think you did. I didn't have them, and that would really grab a hold of parts. I don't know if you would still do that now, unless you just had a part that you couldn't get to stick down any other way. You could do that. And they make little chambers and all sorts of. If you look up ABS vapor smoothing, there are all sorts of ways that you can use acetone to smooth out ABS prints. I don't have one handy. Let me show you kind of what the results look like. Just in a picture here. Let's see if I can find a good one. Yeah, here's some. So here's the Buddha Yoda printed, vapor smoothed, or I don't know if they did vapor smoothing or just acetone. The vapor smoothing is you put it in a container, put the acetone in a container, heat the container slightly. You don't want it to explode or anything, but enough. Acetone evaporates in air basically, so it doesn't take a lot of heat to get it to evaporate. And then the vapors surround your part and smooth it out. So this glossy finish on all of these, that's just from being exposed to acetone vapor. You don't even have to heat it. You can put like a big pickle jar with some paper towel soaked acetone in the jar, and just that vapor evaporating from there will create some. You can get some worse results here. This one is better, but it was pretty bad print to begin with, but it did make it better. The longer you leave it exposed to the acetone, the more the more smoothing you'll get. So you'll lose details. You can kind of see, this losing some of the details, but this particular model doesn't have sharp details to begin with. Here's some sharp edges, what they look like after smoothing. So you can, if you're not trying to retain, here's a good example of losing some of the details in the sharpness of the feathers on this print. If you're not trying to retain those, acetone smoothing of ABS is a way to make it look like kind of injection molded part. I don't know if anybody has done a lot of testing on if it actually increases the strength of the part or decreases the strength in any way. I would assume it probably increases it slightly, just because all the outer layers are melted together. They're basically working as one part. The inner stuff still is all, not connected together. In fact, let me show you this. Where'd it go? I was printing a hook and I stopped it midway. So this same hook, but printed midway. And you can see the infill. Oh, can you see the infill? There you can kind of see the infill. You can see the infill. Let's turn this off so all these fans aren't going. I didn't even realize that. So you can see the infill in here, and this is what can happen. The infill almost has no strength. This one wouldn't do that because it's closed on the top and the bottom. It doesn't have this open surface, but infill has very little tensile strength. And it snaps very easily. All I had to do was, just apply a little bit of force to this thing, and it just broke all the infill apart. But you can also see kind of the toughness of ABS here. It has a lot of flexibility associated with it. I don't remember why I stopped this part way, but I did. So this is a pretty pretty durable little ABS printed hook. I haven't had time to, this is all I've printed so far. I basically did this last night. And because I spent most of the time trying to get the fan working right. And finally, once we got the fan working right, then I was able to print pretty nice. This is the only one that was printed with the fan actually working. The non-working fan over here, I don't know why, just having trouble picking up the details in the gray filament. Also, it's pretty dark in there. Maybe we'll put a little bit of light on it. Too much light. So you can see kind of what you can do. I really like how easy it is to sand, particularly flat surfaces. It would be hard to sand in here. These parts would be really good vapor smooth candidates because they have details, but they're pretty soft to begin with, and that would probably be something worth trying. Maybe I can have that as a little mini experiment, on Wednesday, trying to get some of these to vapor smooth just without the heat. I don't really want to use heated vapor smoothing. It does work better that way. You get a lot more vapor, but you also get a lot more vapor, which is very flammable. So I'll just see if we can do the non-heated vapor smoothing to make these into pretty nice pieces. They'll look, store-bought, more or less. Let's see, did I have any? Oh yeah, I had one other thing I wanted to show you. So the ABS filament is one of the more hygroscopic filaments, so it likes to absorb water. And the ABS that I had ordered some, but it didn't come in time. But I had some previously, I did find, but I couldn't remember exactly how old it was. It was open, and it was in a box, a little plastic container box, but I had no idea if it was going to print or not because of just absorbing moisture from the air, because it could have been there for years for all I know. I don't really know. So I do have this. If you're in a place where humidity is a problem, it can even be a problem for PLA. It's not as bad with PLA. PLA generally can last quite a while, even in pretty humid areas, before it absorbs too much moisture to print well. ABS, that is a much shorter time. Flexible materials like TPU, that's a very short time. Carbon fibers, nylons, they suck up moisture pretty fast and won't print very well. So if you're ever printing and you hear like Rice Krispie sounds from the nozzle, that's too much moisture in the filament. And it'll generally result in, if it prints well, it'll look under extruded, it'll have bubbles around it and things like that. It just won't be a nice surface finish. So in order to head any of that off, what this is, and there's several of these, this one is basically a tiny little oven that you can put one roll of filament in. It plugs in back here. The plug-in's over there. It has a little control panel on the front, and you can basically cook your filament at 55 degrees Celsius for 5 or 6 hours. So I did do that to this roll of filament, just on the assumption that it was an old roll that probably wasn't going to print very well, and it is printed perfectly fine. And I didn't try without doing this, so it might have been fine anyway. It was at least in a box, but these little things, if you do have consistent trouble, or you print materials like flexibles that absorb moisture really quickly no matter where you are, then stuff like this is pretty handy. The other thing you can do is they make passive boxes like this where it's just a container and you put desiccant in it. So you can get giant bags of desiccant pretty cheap. And at that point you could just, any container that is airtight, you can put your filament in there, cover it with desiccant in the bottom of the container, and it will suck the moisture out. The only problem with desiccant is that at some point it will become laden with moisture and then it doesn't work anymore. There are some resettable, like you can basically cook the desiccant and get the moisture out of it and it works again. But at that point, I don't know, it seems like it's just simpler to get more desiccant. But that's the nice thing about this one. It doesn't rely on desiccant. It does rely on heat. And so it does have a tiny little heater in there and a little bit of a controller that keeps it at a certain set point temperature. So let's see how much these are these days. They go around in prices all the time. And I don't know where they're currently at. Let's see. Hey, actually right now they're pretty cheap. $40. I think when I first got this, or first saw these, they were $80. So yeah, 40, that's not bad. And it works well enough. At least, I haven't actually gone in. I don't have a moisture sensor to go in and measure the moisture of a filament before and after, but I do know that, I don't know for this ABS filament that I'm using right now, but I do know that I have had filaments that would not print well, put them in the box for a couple of hours, and then they printed fine. And depending on where you live in Arizona somewhere, it's pretty dry, and you probably don't have this to worry about at all. But other places are much more humid than that. Actually, Arizona's in their monsoon right now, monsoon season, so it's actually pretty wet right there today. They make some double ones, but they're not crazy. So if you're having consistent problems with filament that is wet, these things do work, and they are reasonably priced now. When they were 80-ish, $70, $80, that's kind of maybe probably not that good. $40 I could kind of see reasonable cost for it. Your roll of those filaments that are this way, typically it's the more expensive filaments. ABS is not, but the TPUs and the carbon fiber stuff, those are $40 a roll at least for most of the good brands of that type of material. And so you're looking at basically buying a roll of filament cost to keep that roll good. So it's probably worth it at that point if you're printing the more hygroscopic materials. All right, next time, what I'm thinking, what am I thinking? I actually think I'm going to move. I don't know if we'll want to talk about stepper motors. We've actually talked about E-steps before. Sometimes I do go in and like take apart a stepper motor and talk about. I'll probably still do that just so you can see and get an idea of what's going on. Just not a whole day of stepper motors. We'll put something else in there. So if you give me some ideas, then we'll put those in. Otherwise, I might move on to this photogrammetry stuff. I did, I don't know if you noticed or not, but I did go and finish up the topology we were going to do the Fusion 360. We'll do that. The Fusion 360 generative design, we'll do that on Wednesday. But I did finish up the topology optimization in SolidWorks. I just had a license issue. I had to go check out a license to get it to work. And those videos are on YouTube also. There's two parts to them because it took an hour and a half or whatever to run the simulation. So I did up to this running of the simulation, and then the second video is an hour and a half later after the simulation finished. All right. I will see y'all Wednesday. We'll do, before I forget, let me write down that we will do Fusion 360 generative design and maybe stepper motors. It depends on how long. That'll probably be a good, while we're waiting on Fusion 360 to do stuff, we can talk about stepper motors. And we probably don't need to talk about E-steps. And quiz 2 will open. That's fine. There we go. All right, I will see y'all on Wednesday.